Okay, welcome back to the bench for this EMS 256 repair. Things are not looking great for it at the moment. When I turn it on and stop and clear, I've been monitoring the inputs, which is coming from BeatStep Pro down there, and I've got a selection of outputs monitoring as well. And if I move output A, we can see that moves output B, output C. So the outputs are driving voltages. And if I hit play on the sequencer, sending a note on and off, and this blue line is note pitch. And if I hit play, sometimes it triggers the note and sometimes it doesn't, and I'm getting no pitch output at all, and I can't seem to record anything. The only thing that's getting through is this gate here, and actually I should be able to show you this. If I send that to 4, we can see that it's actually triggering that 4th gate plugged out there. So only 2 gates have outputs, but they're not being recorded. So maybe we should check some more voltages first. Okay, this got personal now. You can see it says Electronic Studios Bournemouth, which is where I'm based. And the 256 I think was designed around the same time that I was born. So I just started pulling some cards out, and there's a cap here. It's measuring in-circuit leaky, so I think it's probably best I might replace all these caps in these boards. And whilst I'm doing it, I can take photos of the boards and then work out which boards are which on the schematics. So the triggering is working much better now, and that's the triggering out of the first layer, and you can even see that the storage needle is filling up. If I make it go faster. And if I go to layer 2, I have to turn the modular off. But there's no layer 2 key output. That should be that top one on that top scope. If I go to layer 3 is now working, and that was one of the sockets that had an X by it, so that's good. And if we go into layer 4 and I take that oscilloscope into there, then we can see 4 is working. I'm still not getting any CV outs yet. Actually, I just thought of a really cool little test that we can do. So we'll start off the BeatStep, and we're recording key input, or triggering from the key input into the first layer, and you can see the needle is moving to show we're filling up the memory. And if I put that into layer 2, the needle still shows that we're filling up the memory. Layer 3 still shows, and layer 4. So if this is reading after the analog to digital conversion, that is a good sign. So unfortunately we've still got no CV outs, and gate key number 2 isn't working, and bringing in information triggering from the pitch doesn't seem to fill up the memory. So I've decided to try and match up the schematics with the boards. Some of them are really easy. This one does say it's G. So I took this one out just to have a quick look, and I know that the 7400s break a lot because I've had them in the Oberheim expander and the LM1, and lo and behold, this one here had gone faulty. I've got it here. So the gate 4's not working. I tried this back in the unit, but unfortunately it didn't make any real difference to the usage. So that definitely saved us a bit of time later on. So we've still got a lot of work to do. I don't quite feel it's going to be very time effective randomly pulling out all the chips, and also I don't really want to damage the PCB traces. This is really fragile, being over 50 years old. So I was able to buy this blank board from EMS, which is really cool. It's actually a copy of the K board, and they were also able to dig out a couple of old 30-pin EDACs, which I might be able to fashion by cutting them. And I was thinking an easy way to do it, when these are cut to length correctly, is to glue them onto the board and then run wires that end up onto the edge connector. It's only 60. I had considered making a PCB way, which I might still do depending on how well this goes. The ones out of the machine have this little cutout here, which hasn't been done on this one, so I'd have to cut that out as well. Okay, while I've been waiting for this to dry, I think I'm actually going to change my approach as to how I'm going to go with this. This is looking good. I need to trim off these so it slides in fully. I need to wire 60 contacts, which should be fun. But I thought I'd have a look. I don't know if you remember, there was a faulty IC on that board. In fact, let me just show you what I found, because I've managed to marry everything up. So board M is what's called a time extender. Not too much on there. I haven't checked this board yet at all. So this one I have checked, which is the recirculation memory. And this one had that logic IC failed. And K is actually a duplicate of that same board, and that had 2 logic IC fails on that one. And we have board J, which is the real-time counter. Now, because the clock is working, I think board J is going to be in pretty good shape. So might leave that till last, although probably still worth socketing everything. Any of these logic ICs could go at any time. Okay, we have board H, which is the data logic control, which is probably again okay because all the start, stops works, rewind and all that jazz. Board G is another recirculation board, so effectively it's RAM, I'm guessing. And this one had a faulty IC on it. Board F is the D to A, which we have no outputs, so we need to check that one out. Although if we've got no A to D going, then that could be okay. And then boards C, D and E are all identical. And this is D to A's as well. So they all look the same. Board B. Now this is the A to D board. And strangely, these are the only ICs that are socketed in the unit. So I went through this board and found 1, 2, 3, 4, 5, 6 faulty ICs. So no wonder there was no analog to digital conversion. And then board A is the real-time clock gen and the slew input, both of which work. So I'm sure that board is okay. I'm still thinking of replacing everything in sockets, because if they fail in the future, it's going to make it much easier to repair. And lastly, this Z board, the only other schematic that I have left unaccounted for is this one, and that's got some SN7441s. This has only got op amps on it, so I'm not sure what board Z is doing at this moment in time. Okay, I've gone through every single board, written down what chips it uses and how many. So I was able to work out that this is the condensed list of all the chips it's using. All the ones in green I've either got or can order. Some of these others might be a bit more tricky. And I've worked out that I need 24 16-pin sockets, 80 40-pin sockets and 24 4-pin sockets. I know that seems quite extravagant, but that's only like £100, and because I can check pretty much all these logic ICs, it's definitely worth put them in a socket, check them, and replace if necessary, because we know after seeing how many have gone already, I'm sure there's going to be quite a lot more. And then once that's done, either it might miraculously work, or then we can carry on with the extender board to carry on fault finding. So anyway, I'm going to order those parts up. Stay tuned for the next episode. Catch you next time.